In the proposed framework we assume that an autonomous system can plan and execute robotic tasks while a human operator can provide interventions when necessary. User interacts both with high-level control modules such as task and path planning that directly with the teleoperation module. In the first case, user requires the autonomous execution of robotic tasks. In the second, he can modify the planned trajectory during its execution. With the use of the remote controller, planned trajectories can be directly modified by the human interventions. The trajectory planner can be continuously invoked to adjust the current trajectory. For this reason, every trajectory is generated exploiting a fourth-order spline concatenation method that preserves continuous acceleration and allow the trajectory switching without halting the robot. User can drive the robot inside a sphere that follow the planning known as teleoperation space. If the user drive out the robot from this sphere, the autonomous system generates another path and trajectory to overcome all waypoints planned in the previous planning. The proposed control framework is supported by haptic feedback to increase the perception on how the robot is far and in which direction is the planned trajectory. The higher the distance between the robot and the planned trajectory, the higher should be the force that the system provides to the human to bring the robot back to the planned way. We tested the effectiveness of the system both in virtual environment and in real scenarios. In each scenario, user has to move from a starting position to a destination point following a planned trajectory, passing through some rewards putted along the path of the robot. The performance of the system are evaluated on the base of the number of rewards that user get, and the number of times that it drive out the robot from its sphere, comparing results the system with and without force feedback support. This video show a real-world test case scenario. In this context, the initial trajectory is a linear path of 3.5 meters navigated in both directions with a movement of 7.0 meters. The user tasks is to reach two virtual landmarks outside the planned trajectory. These landmarks appear on the left screen in a virtual reality environment and becomes visible to the operator when the robot distance becomes less than 1 meters.